Hello. Now we will start trigonometric methods for integration. Here we have our first example, integration of sine cube of dx. Okay, let's note down the Pythagorean relation for sine and cos, which is, so let's start. Whenever we have odd power of sine, then we will break down this integrand sine cube x into two parts. Sine square x times sine x dx. Okay, sine square x can be changed into 1 minus cos square x, so let's write that down here. So which is integration of 1 minus cos square of x and sine x dx. Now let us suppose that u equals to cos x. Okay, so we use u substitution. Its differentiation is u equals to negative sine x dx. Then the integral becomes 1 minus u square sine x dx would be negative du. So that can be written as u square minus 1 du. This is u cube divided by 3 minus u plus c. Don't forget to write that. So u is cos x, so we can write this as cos cube x divided by 3 minus cos x plus c. So that's our answer. Here what we need to understand is, if we have odd power of sine, break down one sine x and attach it with dx and convert sine square x into 1 minus cos square x by the Pythagorean relation. So let me just show you the solution for integration of cos cube x, which is similar. So you can see here I have solved the integral cos cube x dx. So pause the video and go through this solution. It's quite simple and similar to the previous one. Consider another problem, integration sine to the power 4x dx. So here you can see that the power of sine is even. So let's see how to solve. So before we solve these kinds of problems, let us note down two formulas. Here we can see the formula cos square equals to 1/2 of 1 plus cos 2 theta, and sine square theta equals to 1/2 times 1 minus cos 2 theta. So you can see the original formula is cos 2 theta equals to cos square theta minus sine square. This becomes sine square x whole square dx. Whenever you have an even power of sine, then we always write in this form. Okay, sine square to the power whatever we need to write down there to come up with. Okay, here this is 2 times 2 is 4. So now let us change this sine square x by using this formula, 1/2 of 1 minus cos 2 theta, which becomes 1/2 1 minus cos 2 theta whole square dx. My bad. Let us this is a minus b whole square, so we can write a square minus 2ab plus b square for this thing, 1/4, and then this would be 1 square minus 2 times cos 2x plus cos square 2x dx. Then again we can change this cos square 2x using this formula. So if we let theta equals to 2x, cos square theta becomes cos square 2x 1 minus 1 by 2 1 plus cos 2 times 2x is 4x. So let us plug in this value into our integral. So then we will be 1/4. Let us pull that out, and this becomes 1 minus 2 cos 2x plus 1/2 1 plus cos 4x dx. So this would be 1/4. Let us simplify it first. So this would be 1 plus 1/2 would be 3/2 minus 2 cos 2x plus 1/2 of cos 4x dx. So let us integrate, be 3/2 of x minus 2 sine 2x divided by 2 plus 1/2 times sine 4x by 4 plus c. Don't forget to write that. So this would be 1/4 of. Let us multiply 1/4 with all of these things. So this would be 3 divided by 8x minus 2, and 2 gets cancelled. So we will have 1/4 of sine 2x plus 2 times 4 is 8 times 4 is 32 sine 4x plus c. So that's our answer. Similarly, I have solved another problem which involves even power of cos x. So please go through this problem, pause the video and look at the solution. Okay, now let's do another problem which is definite integral, which includes sine and cos. So here we have integration 0 to pi sine cube theta cos to the power 4 theta d theta. We can again use the similar kind of techniques that we have used in previous 4 problems. The power of sine is odd, so we can break down this into sine square theta times sine theta and change sine square theta in terms of cos and use u substitution where u is cos. That way we will solve this problem. So what I would like to suggest, it's better to solve the indefinite integral at first, and then after you have solved the indefinite integral entirely, then you can plug in the upper and lower limits 0 to pi. So let us go for that. So let me copy down the indefinite part, which is integration sine cube theta cos to the power 4 theta d theta. Split this down into sine squared theta times sine theta times cos to the power 4 theta d theta. By our Pythagorean identity, we can write this down as 1 minus cos square theta, since sine square theta can be written as 1 minus cos square theta, times cos to the power 4 theta and sine theta d theta. Let us do the u substitution, where we would consider u to be cos theta. Okay, then this becomes du equals to negative sine theta d theta, or simply we can write negative du equals to sine theta d theta. 1 minus u square u to the power 4 times sine theta d theta is negative du. Let me multiply negative u to the power 4 to both of 1 and negative u square. So that will give me negative u to the power 4 plus u to the power 6. Negative u to the power 5 by 5 plus u to the power 7 by 7. All right. So negative 1 by 5 is cos to the power 5 theta plus 1 by 7 cos to the power 7 theta plus c. So now once we have already done the indefinite part, so let us go to figure out the definite part of this integral. Okay, so here I have written down the definite part of the given integral. Integration 0 to pi sine cube theta cos to the power 4 theta d theta would be the solution, negative 1 by 5 cos to the power 5 theta plus 1 by 7 cos to the power 7 theta 0 to pi. Let us solve this. So we would just plug in the upper limit minus plug in the lower limit. Okay. Here you can see that we have plugged in pi to this expression, which would be negative 1 by 5, and cos pi is negative 1 to the power 5. So that's fine. So this is 1 by 7 and cos pi is negative 1 to the power 7 minus 1 by 5 is there, and cos 0 is 1. Cos to the power 5 makes it 1 to the power 5, and minus 1 by 7 times 1 to the power 7. Okay, so you can easily see that this would be 1 by 5, this would be negative 1 by 7, this is positive 1 by 5, and this would be negative 1 by 7, which will give us these two will give us 2 by 5, and these two will give us negative 2 by 7. I have pulled this 2 out of both of these expressions. So then this finally becomes 2 times 7 times 1 is 7 minus 5 divided by 35, right? 35 is the LCM of this expression. So this would be 2 times 2 is 4 divided by 35. So that's our definite integral. So that's our answer. Okay, so we have solved the solved this kind of definite integral. Now it's your time to solve this problem. So let me write down the exercise for you. Please do this problem. 0 to pi by 2 cos cube theta times sine to the power 4 theta. So it is similar kind of problem to this one. Please go through this problem. Okay. If you have any questions or concern, please do not hesitate to leave a comment. Okay. Thank you. See you in another lecture. Bye bye.